Hey guys, in this video we're going to be doing Target 2C.5 and our master learning objective is being able to solve quadratic equations by factoring to find the x-intercepts. So a quick recap, remember when we were graphing our x plus 2, x minus 1 and I asked you to find the x-intercepts? All we did was, remember to change the signs. Right? So if I had that x plus 2, what I said that my x-intercept was the opposite. X is a negative 2, right? And then I would go graph that point. X is negative 2, right there. And then I looked at my next point, which was x minus 1. That made my opposite sign, so that means that if an x is at a positive 1, and that would be graphed right there as my x-intercept. I also seen that that was a positive binomial, so that's going to be opening upward, making it look like a upwards U. And then I can just go ahead and figure out the rest of what my function looks like. Again, please make sure it looks like a U. No like strong harsh points between these. We want to go up and then over. Arrows at the end indicating that that does go up forever. And then we moved on to the next example, right? Well, we're going to be doing the exact same steps here. We just have to get our quadratic into factor form. So I want to get it into that x plus 2 or x minus 1, something that's in binomial, two binomials, so that I can take the opposites of them and find the x-intercept. So the steps of how to solve these are right here, right? Number 1, it says set the quadratic equation equal to 0. We need to make sure that all the terms are over at one side and that my equation is equal to 0. I do see that my example here is equal to 0, so I do know that my first step is done, right? It's already equal to 0. Next step says factored using any method. When we used our Punnett square boxes, I see that coefficient of a 1. So I do know that my Punnett square box then is going to have that x squared up in the top left. Again, if you use a different method, that's okay. That 15 goes in the bottom right. And now I'm thinking of a number that multiplies to 15. So it multiplies to 15. LTI. And then it adds up to 8. So two numbers, again, using your factor chart, your multiplication table. Numbers that multiply to 15, I think of 5 and 3. 5 and 3 can be added to get 8. So those are actually the numbers we're going to use here. So 3 times 5 is going to give us 15. And then 3x plus 5x gives us our 8x. So those are going to be those two numbers that I do put on my Punnett square box, fill in those blanks. And then fill out what the outside looks like. So this is going to be an x plus 3, and this would be an x plus 5. All right, but that's just my binomials. I'm not done with the question because it's still, I have a step 3 that says identify the zeros. Zeros is just a fancy word for saying the x-intercept. So remember that. Zeros. Also in your calculator, those of you that use it to find the x-intercepts, you will already know that zeros are not x-intercepts. Okay, so my binomials, x plus 3 times x plus 5, still equal to 0, right? Because the whole equation is equal to 0. Now I want to find my x-intercepts, just what we did up in the top. This means x is going to equal a negative 3, and this means x is going to equal a negative 5. Each of those set equal to 0. Basically, just take the opposites of each. All right, let's give it a try on the next example. Number 2. Well, my first step was set the quadratic equation equal to 0. This is not equal to 0. So I'm going to go ahead and do my dotted lines because I want that 14 to be over to the other side with everything else. So what I'm going to do is I'm going to subtract 14 on both sides. That's going to give me w squared minus 5w minus 14 is equal to, well, 14 minus 14 is 0. Now I have my quadratic equation equal to 0, and I can go ahead and factor. Draw my Punnett square boxes here. All right, I have w squared in the top left, negative 14 in the bottom right. So if I multiply to a negative 14 and add to a negative 5, I need numbers that have alternate signs. So something that negative and a positive, multiply to 14, add to negative 5. Messing around with those numbers, you'd get a negative 7 times a positive 2. Right? Negative 7 times a positive 2 gives me a negative 14. And if I were to combine those together, right, negative 7x plus a 2x would give me a negative 5x. So each of these two terms are what I'm going to place on the inside of my Punnett square box. Don't forget their signs. So this is going to be a w minus 7 and a w plus 2. But I'm not done yet because our equation was set equal to 0. So w minus 7 times w plus 2 equals 0. I set each of these equal to 0, and I'm going to have w equals 7 and w equals a negative 2. Right? Those are my x-intercepts. SU x-intercepts, that is how we must state it. All right, let's move on to the next example here. Example number 3 says 4x squared minus 16x minus 12. Now, if you could do me a favor, there is a typo on this example. This should say a plus 12. So that, again, that's a typo. Please fix that. It's a plus 12. All right, so y 4x squared minus 16x plus 12 equals 0. I have that coefficient, though, in the front that's bigger than a 1. So the first thing is, well, is there a GCF? Can I divide that first coefficient by everything? Can 4 divide by 4? Yes. Does 16 divide by 4? Yes. Does 12 divide by 4? Yes. So therefore, my GCF that I'm going to remove out is a 4. So I'm going to take that 4 out. By dividing every term by 4, I'm left with x squared minus 4x. Again, that's a positive 12 divided by 4, which is a positive 3, still equal to 0. All right, I am equal to 0, so I'm good to go with just factoring using my Punnett square. So x squared and my positive 3. So a number that multiplies to a positive 3 but adds to a negative 4 means that both numbers have to be negative. So that's going to be a negative 3 times a negative 1, right? That's a positive 3. And if I were to add these together or subtract them, I get a negative 4x. So each of those terms, negative 3x and a negative 1x. Don't forget those negative signs because they will change the problem completely. So the outside is going to be then x minus 3 and an x minus 1. Can't forget my coefficient in the front, right? 4 times x minus 3 times x minus 1. So again, don't forget to bring this guy all the way down. He's still part of the GCF. All right, but I'm not done yet because I still need to state my x-intercepts. Taking the opposites of this, that means x is going to equal a positive 3 and x is going to equal a positive 1. Don't worry about that 4 because technically you would set it equal to 0 and 4 does not equal 0. All right, next example here. I have to make sure that everything is over on one side and my equation is equal to 0. I see that x squared there all by itself, so I have to move all those other terms over to the left side. So if I'm subtracting 2x, the opposite of that, the inverse, would be adding 2x to the other side. And I also see that positive 3, and the opposite of that would be subtract 3. So now what I would have left is, on the left side, everything would be over there. X squared plus 2x minus 3, all equal to 0 now, because everything on that right side did move over. I can go ahead and factor this. Again, if you don't like using the Punnett square box and you want to use a different method, that is okay. Something that multiplies to a negative 3 but adds to a positive 2. If they're multiplying to a negative but adding to a positive, that means they have alternate signs. So 3 times a negative 1 is a negative 3. And 3x minus x, or 1x, would be a positive 2x. So each of those terms would be inside each of those boxes, 3x and a minus x. I have an x plus 3 then, and an x minus 1. Each of those binomials multiplied together equal to 0. Have to find the x-intercept, so I set each of those equal to 0. Take the opposite of each. So that would be negative 3, and this would be a positive 1. Oops. X equals a positive 1. I guess you don't need the plus sign. So you can just have x equals 1. All right, last two examples here. Looking at number 5, I have, sorry. All right, number 5, x squared equals 12. There's also a typo here. Typo, sorry. This should actually say 3x squared equals 12. So again, 3x squared equals 12. That was a typo. We want to get everything over to one side, so I'm going to go ahead and subtract that negative 12 over to the other side. I want it to be equal to 0. So therefore, I have 3x squared minus 12 equals 0. I want to deal with nice numbers. I see that that coefficient is a 3, and the first thing I think of is their GCF. Can I take a number and divide both of these? And I can. My GCF would be a 3. So if I take a 3 out of each of these, divide each by a 3, I end up with x squared minus 4 equals 0. Now, working with these problems, you have to start getting good at recognizing certain patterns. And the first thing I see is, well, I only have 2 terms there, but I am subtracting. And the first thing I would think of is, well, is this a problem that's the difference of squares? And we can check that. If I have the square root of x squared, that's x. That works. Square root of 4, well, square root of 4 is a 2. So that ends up being a perfect difference of squares problem. So all I have to do then is write 3 times x plus 2 and x minus 2. When I find my x-intercepts, setting each of these, oh, I forgot, whole problem's equal to 0. Taking the opposites, so x is equal to a negative 2, and x is equal to a positive 2. All right, those are my answers right there, x-intercepts, and I can go ahead and move on. Last example here, 5x squared minus 20 equals 0. First thing is, well, I don't see a nice number in the front there, but I do see a 5. So the first thing I think of is there a GCF? If I take that 5 out, does it divide each term? And yes, it does. 5 does divide 20. So our GCF again in this example, we have to take that out, which would be a 5 in this case. I'm drawing a line here. Remove that 5 out is going to be left with, if I divide each term by 5, that's going to give me x squared minus 4 equals 0. I do see only 2 terms there, and I'm subtracting. So again, I think of that difference of squares problem. X, if I take the square root of x squared, that's x. The square root of 4, that's 2. So in this case, it becomes 5 times x plus 2 times x minus 2, still equal to 0. If it's equal to 0, I have to state those x-intercepts. So x is equal to a negative 2, and x is equal to a positive 2. All right, that brings us to our last example there, and you can go ahead and work on 2C.5 activity. Good luck.